Hello, welcome everyone to stackconf. Thanks for having me. My name is Ara Pulido. I'm a technical evangelist at Datadog. And today I'm going to be talking about policy as code in Kubernetes. So that's my Twitter handler. So if you want to reach out before, after the conference, please do so. Again, we are going to be talking about policy as code with OPA and Gatekeeper in Kubernetes. So first of all, what is Kubernetes? Probably many of you already know, but basically Kubernetes is a container orchestration platform that help you run your containerized applications in production. And it has super nice features like it's completely API driven. It has features like auto healing, auto scaling, etc. So very useful, very successful project, open source project. And today we are not going to be talking about Datadog itself, but just so you know, I'm working for Datadog, which is a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications. And obviously that includes Kubernetes, the cluster, so helping you understand what's going on your cluster, and also what's going on your application that you're running on top of your cluster. But today we are going to be talking about policy and what is policy, particularly when we are talking about software. So basically policy are the rules that governs the behavior of a software service. Basically what you can and cannot do in your cluster. And when we talk about what you can and cannot do in your cluster, if you already know Kubernetes, that sounds very familiar. That sounds like RBAC. And RBAC stands for Role-Based Access Control. And RBAC is already embedded in Kubernetes. It's well spread, well used. And basically RBAC, what it does is that the rules are defined as a subject, a Kubernetes API resource, and a verb. So, for example, user Ara, for the type of object pod, she can create, get, and watch those resources. So that's how we define rules in RBAC. So if we already have RBAC and it's well understood, well known, why do we know something? Why do we know we need something else? And the reason why we need something else is because auth, which is what RBAC tries to solve, is just a subset of all the different policy that you want to describe in your cluster. So things that, for example, you cannot do using RBAC. Answer questions like, can I run an image coming from a third-party registry in my cluster? Or has my pods all the labels that are required by my organization? All these type of things are not, cannot be defined with RBAC. RBAC basically says what the verb, the thing that you can do for an object, but not what it's inside that object. So this is for Kubernetes, but probably your organization have more infrastructure, not just Kubernetes. They may have service meshes or gateway APIs or cloud resources or stateful resources. So you want to create policy not just for Kubernetes, but for all your infra. And possibly, if you can, you want to do it more or less the same way. And this is what Open Policy Agent, or OPA, tries to solve. So OPA is a CNCF project that does exactly that. It tries to have a very not domain-specific way to define your policy. So how does it does that? So basically, you can define your policy on a domain-specific language called Rigor, and you can have some data stored about your objects if you want to. And OPA is an engine that basically takes a query in JSON and then basically makes a policy decision and returns that policy decision also in JSON based on the policies that you have registered in Rigor and the data that you have. That's the only thing that it does. It takes JSON, it outputs JSON, and that's all it does. So once you have that policy decision, made by OPA, how do you enforce that from happening automatically? So the way you do that is with the many integrations that you have for OPA. So if you go to the OPA website, there is a list of all the possible integrations, and many more are coming every day because basically it's very easy to implement. It's also all using JSON, so fairly simple interface. So you have many different of these integrations to enforce OPA policy decisions depending on the infra that you're having. And Gatekeeper is basically that. Gatekeeper is an enforcement of OPA policy specifically for Kubernetes. And the way Gatekeeper does that is by embedding OPA as part of its binary. So it basically embeds OPA as a library that it's part of this code to make those decisions. So how does Gatekeeper work? To know how does it work, it's important that you know that when you make an API request to Kubernetes, it goes through several phases. It goes first from authentication, is this request authenticated or not, then through authorization, mostly RBAC. And once that's authorized, it goes to the third step called admission controllers. And admission controllers are embedded already on the API server, and basically you can do more complex rules. You can, based on the content of that request, you can either validate that one, is this correct or not, through a set of things that I have defined, and also to mutate them. Like if you want to make some rules that actually change, that can be done as well with admission controllers. And there are two very particular ones on those list of admission controllers that has the Kubernetes API server, which are validating admission webhook and mutating admission webhook, which basically allows you to hook any code that as a webhook to those. So that's where Gatekeeper gets implemented. So basically it's a webhook to those admission controllers, so you can do basically anything you want. And that's a very classic way to implement these things in Kubernetes. One of the great things about Gatekeeper is that it was Kubernetes native from day zero. So that it wasn't creative thinking about that it was going to be used in Kubernetes. And it uses a design pattern very common in Kubernetes of extending the Kubernetes API through CRDs, custom resource definitions, and then have a controller that does this reconciliation loop that we all know and love in Kubernetes. So you create something as an object, and the controller does something based on that. The good thing as well is that it creates two main CRD objects, the constraint template one and the constraint one. And this means that you actually can reuse constraint templates into several instances of different constraints. And we are going to see an example to explain more or less. So we have this constraint template to require a set of labels. But instead of putting here the labels that I require, I leave it as a parameter. So that way I can do many rules based on this template by instantiating that constraint template into constraints. In this case, for example, I'm saying that namespace is required to have the Gatekeeper label, and my pods, for example, require the do not delete label, but only on the default namespace. So that way you can reuse these rules over and over again without having to write a lot of Rego. And that makes Gatekeeper great to reuse policy. And the funny thing is that many of the things that we want to govern in our cluster are very similar from organization to organization, like things like images can only come from approved registers, or deployments require certain mandatory labels, or container images must have a digest, or containers need to have a memory and CPU limit set with a specific value. These are things that probably you want to do on your clusters as well. So the Gatekeeper project, the OPA part of the OPA project, has created the Gatekeeper Library, which basically is open source library of these constraint templates. So for many things that you already want to do, probably you don't even need to write any Rego or understand even how Rego works, because there are already a lot of ready to be used templates. And on this particular Gatekeeper library, you have two things for each of the rules. You have the template, and that's the thing that you will apply on your cluster. But also you have examples of how to use that template. And you have that example with two things. You have an instantiation, a particular instantiation of that template, and also an example that will fail that rule for that particular constraint. So in a very easy way, you can see how a template works, how to use it, and what are the type of objects that will deny, that will basically fail validation. Cool. So that's completely open source. Not only Gatekeeper, not only OPA, but also the library. So if you go to that GitHub URL, you can go and see all the different templates. Another great feature from Gatekeeper is that it has a lot of metrics already set up for you. So this is very important because you want to understand what's going on when you create a new policy, see what objects are already failing that policy, things like that. So it has a lot of out-of-the-box metrics, like the number of constraint templates and constraint, the request to the webhook per second and the latency, the number of violations, so the number of objects that are violating a particular rule, and how much data we are going to have sync for that rule to happen. So we are going to see some of them during the demo. And the great thing is that in a Datadog we have out-of-the-box integration that without you having to set up anything, it will have an out-of-the-box dashboard with all the data that you're interested in about your Gatekeeper policy. And again, we are going to see that in the demo. So let's have a look at the demo now. So we have, so by the way, I've had alias kubectl2k, so every type at k is kubectl. So we have a very simple one node cluster. So in this case, using Minikube, it's good enough for the demo. And one of the things that we have is that we already have Datadog up and running here. So because we have Datadog up and running here, you can see that we have all the data about our cluster over here. All the pods are already running. You can see that Gatekeeper is not running yet. And we have a couple of namespaces, the full namespace and the kubesystem namespace. Good. So we are going to now deploy Gatekeeper, and we are going to deploy Gatekeeper in the most simple way. So basically, we are going to apply the full YAML that it's on the getting started instructions from Gatekeeper. So you can see that it has created a bunch of new resources. One of the things that it has created, it's the CRDs, the new objects that extend the Kubernetes API. And we can see that the ones that we, for example, talk about during the presentation, the constraint templates. Great. So let's see if we have also a new namespace called Gatekeeper System. So if we check the pods over there, we can see that Gatekeeper is already running. So you can see that we have 4 different pods. So the first one is the controller. So that's the one that creates the reconciliation loop. And you can see that we have 3 replicas here. It is recommended to have more than one replica, because if it fails, then you can create any pod without or any object without going through policy. So to have an HA deployment, at least more than one replica is recommended, but you can define that. And also we have a 4.1, which is the audit. And this we are going to explain in a second what it's for. Cool. So now that we have Gatekeeper running, what is going to happen is the Datadog agent is going to auto-discover that this is here. So if we see, we can see here the Gatekeeper check up and running correctly. So what that means is that the Datadog agent auto-discovered that was happening, and it's going to start gathering metrics for that particular one. For Gatekeeper, specific metrics from Gatekeeper, and moving them to Datadog. Cool. So let's start creating our first policy. And for that, what I'm going to do is I'm going to be using the Gatekeeper library. And the reason why I'm using the Gatekeeper library is to show you, again, without needing to know Rego to start with Gatekeeper, how I can reuse that for my own policies. So we are going to use, you can see here, this is the Gatekeeper library repo. We just cloned it from the internet with all the different templates. And we are going to use the required labels that we saw as well. So basically, when you see one of these templates, you can see the description here. So you can know what it's going to do. You're going to have the different parameters. And then you're going to have the Rego code here. So again, to start with Gatekeeper, if you're using the library for many things, you don't need to know a lot. Obviously, if you then want to create your own rules, you will need to understand a little bit more how that works. So the first thing we are going to do is to apply that one. So we have library and general, and let's say require labels. So we apply the template. That's the first thing that we need to do. And it's going to create the template, and it has to do two things. It has created the Kubernetes require labels type of constraint template, but also it has created a new CRD. In this case, it has created an object for all the instances that we want to do from this template. Okay, so let's get one of the examples, but let's modify it a bit. So we are going to copy this example that we have as part of the library, and we are going to call it, for example, all must have stackconf. Good. So let's again, we just copy that from the library, and we have an example here. And you can see that using also the example, you can quickly create new policies. For example, in our case, we are going to change this to pod, for example. We want all pods to have the stackconf. So we are going to change also the description. All pods must have a stackconf label. And then we are going to remove the validated value. So we are going to say basically the only thing that we need is to have the stackconf label without having to define a particular value. So let's remove this one. And basically, we are going just to see that the key has to be stackconf. We don't care about the value. Okay, saving that. And again, we have to apply that particular object. Okay, we have created that object. And if we now try to create a new pod, for example, this very simple Nginx pod, you can see that it has the label run, but it doesn't have the label stackconf. So what happens when we try to create that object now that we have that rule in place? So you see, suddenly you get a denial error with the description. So it's for your users, for your cluster users, you need to create this constraint with nice descriptions so they get the reason and how to solve it, the reason why their pod is failing and how to solve it. In this case, all pods need to have the stackconf label. So let's do that. Let's quickly add stackconf, and then we can put any value here. And now if we try to create that object, suddenly Gatekeeper is going to allow us because it basically follows all the rules that we have set for this cluster. But we already had some pods. We already had some pods running that didn't have that label because we hadn't created that rule before. So what happens with the pods that were already running? So that's where the audit pod that we saw. So when we were saying that we had this audit pod, this is what it does. What it does, the audit pod, is to check for objects that are already on the cluster that are failing a new rule. And that way you don't have to you can create a new rule knowing that it's not going to affect the workloads that are already running and give people time to modify their workloads. So if we now, if we get this object, which is the one that we have created, and we describe you can see here all the pods that are violating the this particular rule. So you can fix that. But obviously you not always want to go on every cluster and describe this. So again, we are sending all this data back to Datadog. So you can see that as soon as I started creating the Gatekeeper, it started sending data to Datadog because the agent was already running there. And you can see data, for example, about the latency of the webhooks, the number of requests, and also the number of violations, that same number that we saw there. As soon as we created that new rule, it will give you information about all the problems that your cluster has. So that way you can create new rules as a cluster admin and in a just a single view, understand what's going on your cluster, which pods are or which objects in general are violating any of the rules. Cool. So let's now go back quickly to the slides, because we were saying in this case we just created one object that was failing something that it was fairly easy to check. So it has this label or it doesn't have. But what about this type of rule? Host must be unique among all ingresses. So you don't only need the description of the object that you want to create, you also need the information about all the rest of the ingresses. How do you do that? Remember when we were talking about OPA? OPA uses two things to make a decision: the rigor code and also some data that you may store on that system. So how do you store that using Gatekeeper? You use it with a new CRD object that was created as well called config, where you basically say what are the objects that you want to store data about for OPA to make decisions. So in this case, for example, I'm telling it every time that you create an ingress,
sync it, and put it on the data pool so I can make decisions based on that data. So let's have again another demo quickly before we wrap up. In this case, we are going to again use the Gatekeeper Library, and then library general, and unique ingress host, the one that we were talking about. And again, in this case, it not only gives me a template that I can apply. So this is the template, but it also gives me the sync object. So again, super complete, the Gatekeeper library, because I basically also have everything that I need to make this happen. So let's go to the examples here. And we have a single example. And first thing, obviously, we need to create the instantiation of our template. So let's do that. And for the example, you can see that it's going to create two ingresses. So it's going to create the first one, and the host is going to be example host example.com. And then it's going to try to create a second one, but it's going to use the same host name as the previous one. So let's see what happens when we try to create that. So you can see the first one was created successfully. And the reason why it was created successfully is because it was the first time that OPA had seen that host name. But the second one, it gives an error, basically saying that the host name conflicts with a previous one. And again, this was fairly automatic. We created both at the same time, but OPA had already gathered information about the previous ingress object and had successfully created that as part of their policy decision. Good, that's all I had for today. I hope that you've learned about Gatekeeper and, more importantly, how easy it is to get started to creating complex policy decisions using, for example, the Gatekeeper library. Thank you very much, and see you in the next one.